Welcome to the first lesson on EC2. EC2 is the Elastic Compute Cloud, and it's an Elastic service that allows you to launch compute resources on the AWS Cloud. Now, in the AWS world, we call these instances, and they're very similar to virtual machines that you might have on your VMware or Hyper-V infrastructure on-premise. Each instance has an operating system, some storage, and a certain amount of virtual hardware associated with it, including CPU, RAM, and network capabilities. If we go in and try and launch an instance, we can see that we have a few options as to what type of image we choose. An Amazon machine image is a template that contains the configuration for your instance. And you can choose some predefined images here. And what you can see is that you can choose the operating system. So we've got Amazon Linux, Red Hat, SUSE Linux, and Ubuntu. And there's many more. We've got Windows on here as well. And once we've chosen the image we want, we can then choose the virtual hardware platform we're going to put it onto. But just while we're in here, I'll show you that under the AWS Marketplace, you can also find Amazon machine images that come with third-party software such as firewalls and load balancers pre-installed. And you pay a slightly higher cost for these because they include the usage of the actual software as well. And you can also see community AMIs. So these are ones that have been shared by people for public use. And you can see a list of operating systems that you can filter by on the left here. So if we go back to the quick start and choose select, we then get to choose an instance type. Now you'll see here that there's lots of different instance types and they're optimized for different use cases. So you might need an instance with more compute or more memory, or that it's storage optimized, or you might need a GPU, for instance. So you can select from all of these different instance types to get the correct virtual hardware configuration that you need. And that includes the CPU, the memory, the storage, and the network performance. Now we're not actually going to launch an instance right now. We're going to do that in the next lesson. Now before we go any further, I just want to point something out to you. You may notice that sometimes the console looks slightly different on your screen. And the reason is AWS changed the consoles over time. Now usually it's just a cosmetic difference, but sometimes they do make material updates that are quite significant. If you can't find something or you believe it's changed in a big way, please let me know and I'll try and help you, and I'll also update the video. This particular video has been updated because there were a couple of changes that I wanted to include, so you may notice that it's slightly different to the other lessons in the rest of the section. You may also notice that I've got this new EC2 experience up here, and by the time you watch this you may not have this, but at the moment you have the option to choose a new experience. And when you flick that toggle switch, you actually get directed to a slightly different version of the console. Now it's not massively different. The items on the left here I think are pretty much the same, but they've changed the layout in the middle. Now I'm just going to switch it off for now and we'll continue. Now if we go under limits, you can see here the limits for what you're allowed to run in the AWS cloud by default. Now almost all of these limits are extendable if you contact AWS. But by default, you'll find that, for instance, you can only run a certain amount of a resource on AWS. Now, it used to be a per limit basis for how many instances you could run. They changed that recently to a per vCPU. So now you can see that you've got a limit here of 1,280 vCPUs if you want to run an instance of one of these families. On the left here, you can see the instances that are running. At the moment, we don't have any. And you can also then look at the instance types, which we saw before. And this will give you the full list of all the different instance types and families that are available. Now I want to quickly cover some of the pricing models with EC2. If I go here and launch an instance, it's called launching an on-demand instance. And you don't get any discounts, but it's very flexible. You can just launch these and terminate them whenever you want to. But there are a couple of other options. So one of them is reserved instances. And in this case, you can purchase a reserved instance and you can choose the amount of time that you want to reserve this for. Now the options are 12 months or 36 months, so 1 year or 3 years. And this means that you're committed to paying for these instances for that period of time. Now, in return for this commitment, you get a big discount, can be up to 75% off the on-demand price. But of course, you'd only use this for steady state workloads that you know you want to run for that period of time. We also have spot requests. With spot requests, what you're doing is purchasing some spare capacity from AWS at a much discounted rate. So what happens is AWS often have some capacity that's not being used, and they'll give you the opportunity to use some of that capacity at a discounted rate. Now, the caveat with this is that at any point in time, when somebody wants to pay the full rate for that capacity, AWS can shut down your instances. You do get notified, but you need to know that. So people use this, for instance, for large compute jobs that are very expensive normally, and they really need that sort of reduction in cost. So think of large computing jobs that are doing some kind of batch processing. It's very important that your applications can withstand being shut down and terminated when AWS need that capacity back. So you have to make sure that whatever you're running on a spot instance, the data or the state of that application is being saved somewhere. There's a new feature called savings plans. This is very recent. I haven't seen this coming up on the exam yet, but it may well come up on the SAA C02 version of the exam. Now, this is similar to reserved instances, but it gives you the option to choose different compute models, such as EC2 and Fargate, which is a container service. Another option that we have is dedicated hosts. A dedicated host is a physical server in EC2 that you can use the capacity of, and it's dedicated for your use. That means even though EC2 is typically multi-tenant, so you're sharing the underlying hardware with other customers, if you use a dedicated host, you're not sharing the underlying hardware, it's dedicated to you. We also have scheduled instances, and this is where you can purchase some capacity on a recurring schedule. So if you run certain workloads on a recurring basis, but not constantly, then scheduled reserved instances might be the way to go. Another thing we have is capacity reservations. In this case, you're actually reserving some capacity to ensure it's available for you when you actually need to run some resources. Now, AWS have a lot of capacity available, but occasionally they can run out of capacity, so this can be useful if you have a highly critical workload and you need to make sure that you can run it at a certain time. Now, we covered AMIs before, and here you can see the public images and the private images. We don't have any at the moment, but you can see those that are shared publicly. So these are the templates for the software configuration for your instances. We then have the Elastic Block Store. The Elastic Block Store is the underlying storage that's used with EC2 instances. This is block-based storage, and you can choose from a few different types of EBS volume. So you can choose from SSDs, and you can choose from hard disk drives, so magnetic style. Now, with the SSDs, especially with the provisioned IOPS, you can actually choose the amount of IOPS you want. So you can specify the amount of performance you need. Now, we're going to cover EBS in much more detail later in the course. We then have some networking features. So we have networking and security. We have security groups, which are instance level firewalls. We have elastic IPs, which are static public IP addresses that you can allocate to your account. And if you do so, Amazon will provide a static IP to you, and you actually need to use it. If you don't use it, you have to pay. And if you do use it, you don't pay for these. And that's just Amazon incentivizing you to make sure you use public IPs that are in demand. We can also see something called placement groups that we'll cover later in this section, and network interfaces, where you can create what are called elastic network interfaces. So think of it as being a virtual network card that you can move between instances. Now, load balancers and auto scaling, these are a couple of concepts we're going to cover in great detail in this course, but we don't need to go into that now. So that's it for a quick overview of EC2, and we're now going to go into much more detail and actually start launching some resources in the next few lectures. Hi guys, in this lab we're actually going to deploy some instances into EC2. Now what I'm going to do is I'm actually going to launch a Windows instance and a Linux instance. Now you don't have to do both, you can do one or the other, it's up to you, but I'm going to show you how to do both. The key difference is the launch is the same, but it's how we connect to those instances. Now in this lab, I'm just going to show you through how we go about launching the instances and teach you a bit about the theory behind it, the things you need to know to understand the technology and understand it for the exam. And then in the next 2 labs that follow this, we're going to connect to those instances. So there's going to be 1 lab for Windows and 1 lab for Linux. Now the diagram on your screen is essentially the architecture that we're going to create. We have an AWS region. I'm going to use the Sydney region, but you can choose whatever region you like. We have a VPC, and we're just going to be using the default VPC. We're going to learn how to create a custom VPC later in the course. And we have availability zones, and within those we have public subnets. Now you'll remember from the previous section that each VPC, each default VPC, automatically has a number of public subnets. And we just need to use 2. We could put them both in 1 if we want to. It really doesn't make much difference. But we're going to place our instances into those public subnets. So you might be wondering, what exactly is a public subnet and how is it different to a private subnet? Well, the key differences are that we attach an internet gateway to a public subnet, and we have an entry in our route table that points to that internet gateway, and our EC2 instances have public IP addresses. So those are the 3 things. Your EC2 instance must have a public IP address. You need to have an internet gateway which is attached to the VPC, but you need a route table entry which points to the internet gateway. So your instance has a public IP, you have a route table which is assigned to the subnet, and that route table has a route that points to the internet gateway. If you have all of those things, then you've got internet access. Now remember, the public IP can be assigned because the subnet is defined as always providing a public IP address to instances that are launched into it, or you can override that when you actually launch an instance, and we'll see that when we go into the management console. Public subnets will normally be configured such that they automatically provide public IP addresses to any instances that are launched into them, and you can change that configuration setting in the VPC management console. So what we're going to do then, we're going to launch a Windows instance and a Linux instance, and we're going to have an internet client. This is just going to be me connecting from my computer over the internet, and we're going to be able to remotely connect to these instances and manage them. Now we're going to do that connectivity in the next lab. In this one, we're just going to launch the instances. So let's head over to the EC2 management console. I'm in the EC2 management console, and I'm just going to choose launch instance. We now get a selection of Amazon machine images. So you can see we have the Amazon Linux 2 AMI and we have the Amazon Linux AMI. Now for most of the labs in this course, we're going to use the Amazon Linux 2 AMI. So make sure you're aware of that because there are some differences between these two. And for the command line, you'll definitely need to use Amazon Linux 2 AMI if you want to follow along with the commands that I put through on this course. You can see there's also Red Hat, there's SUSE, there's Ubuntu, Microsoft Windows, and so on. So lots of options there. Now you'll also notice some of them have a badge for free tier eligible. So when we want to deploy Windows Server, we want to choose the one that's free tier eligible. And that means you won't have to pay for it as long as you don't use more than 750 hours of EC2 instance time per month. And that's using a specific instance size, which we'll talk about shortly. So I'm going to choose Amazon Linux 2 AMI. But you could also go into My AMIs if you've got your own. You can go into the AWS Marketplace and find AMIs that have been configured sometimes with software from these software providers such as Juniper Networks and F5. And you can also see community AMIs which have been shared by people for others to use. So we'll just go back to Quick Start. We'll choose the free tier eligible Amazon Linux 2 AMI and select. Now we get the option to choose our instance type. And you can see at the top here you can choose by different families. So you've got the micros, the general purpose, the ones that are optimized for compute, or that have GPUs, or that are optimized for memory or storage. And these all have different allocations of CPU, memory, and EBS volumes. Some of them are also optimized for EBS, so they have higher throughput for storage. Others have better network performance. In our case, we're going to just choose this one because again, you can see that it's free tier eligible. So this is the T2 Micro. We'll choose Next. We now get to configure our instance details. We can choose the number of instances we want to launch, and we'll just leave that as 1. We can choose to request spot. So you remember, spot is a way that you can bid for unused capacity on AWS at a lower cost. In this case, we're just going to choose a on-demand instance, so we leave that blank. Under network, you can choose your VPC. Now we only have one, so we can see the default VPC here. And we then have our subnets, and we can see 3 different subnets. So I can choose to put this, for instance, in AP Southeast 2A. Auto assign public IP defines whether my instance is going to get a public IP address. So you remember I mentioned before that for my instance to have internet connectivity, it needs to get a public IP address, and you can define at the subnet level whether an instance will receive one. So here we can see that it says use subnet setting enable, which means it's set through the subnet that this instance will receive a public IP address. You could also override the subnet setting if you want to. We then have IAM roles. Now we're going to talk about those later in the course. We don't have any set up at this stage, but these are a really important concept to understand. We don't need to change any of these other settings at the moment. So what we're going to do is just choose Next for adding storage. Now by default, we'll have a root volume, which is a general purpose SSD. So it's a solid state drive, and we can see the performance characteristics of that drive. We can also see that by default, when we terminate our instance, it will delete this volume, so all data will be lost. You can choose to add a new volume here, and you can select what type of storage you want to use and whether you want to encrypt it. You can even encrypt the root volume. You didn't used to be able to do this at launch time, but now you can. So you can actually encrypt your root volume if you like. I'm just going to leave it as non-encrypted and choose Next. You now get the option to add tags. So tags are key value pairs, which essentially assign metadata to your instance. So for instance, you could say that this is in the department development, and now you'll be able to use that information for reporting and management and so on. So I'm going to click Next, and this is where we get to choose our security group. Now we can either select an existing security group, and all we have is the default security group, or we can create a new security group. I'm going to create a new one, and I'm going to call it web-access, and I'm just going to copy this value and paste it into the description. Now by default it's come up with SSH because we chose a Linux instance, so it's going to allow SSH inbound from any IP address. Now you could lock that down to an individual address or a range of addresses, but we don't need to in this case. Now I'm then going to add another rule, and this is going to be for when we launch our Windows instance. So I'm going to allow RDP, and I'm going to specify the same IP range. We can then choose Review and Launch, and we now get a summary of what's going to be launched. And I'm happy with the details here, so I'm just going to choose Launch. Key pairs are a really important concept to understand. Key pairs are used to access your Linux AMIs through SSH. You can also use them to obtain the password for your Windows AMI. They consist of a public key and a private key file. AWS keep the public key, and you store the private key file. So what we need to do is create a new key pair because this is a new account. I'm going to call mine Sydney-KP, and I can choose download key pair. Now you want to keep this information secure, obviously, because this is sensitive information. You also don't want to lose it because if you launch an instance and then you lose your key pair, you won't be able to SSH into that instance. I can now choose Launch Instances. And if we choose View Instances, we get taken back to the AWS Management Console and we can see the instance that's being launched. We can see it's a T2 micro, it has an instance ID, we can see the availability zone, the instance state as pending, we know it's initializing, we can see the public IP address already, and down here you can see that it also has a public DNS name, which actually contains the IP address within it. If we click on status checks, we can see there's two types of status checks here, the system status checks and the instance status checks. We'll talk about these more later in the course. At this stage, they're both initializing, and within a few minutes we should see that everything is functioning correctly. While that's happening, what I'm going to do is launch the Windows instance. So I'm just going to come down this time to Windows free tier eligible and choose select. I'm going to stick with the T2 micro. In this case, let's put this one into the AP Southeast 2B. Again, it's going to receive a public IP address. All of these public subnets will provide public IP addresses by default. You can see here that you have one Ethernet interface assigned to each of these instances, and you have a primary IP address which is dynamic, and you can add secondary addresses and IPv6 addresses if you want to. You can also add additional network interfaces. Let's choose next. We're going to leave storage as default. We don't need to add any tags. I'm going to go up and select my existing security group and choose web access, and then I'm going to go review and launch. And this time we can actually select our existing key pair, and we have to check this box that acknowledges that we have access to the private key file. And this is just a warning really, because if you launch this instance and later on realize that you didn't have the key file, you wouldn't be able to access it, so that would be a problem. I'm just going to choose Launch Instances. We now have both our instances launching. The first one we can see is running and it's passed both checks. The other one will just take a few minutes. So we're going to leave this lab here. What we've done is we've launched two instances into two different availability zones. One is a Windows instance, one is a Linux instance. We've created a new security group that we can now use to access them. So for Windows, we're going to access it over RDP, port 3389. And for Linux, we're going to access the instance over SSH, port 22. And that's what we're going to do in the next two labs. Hi guys, in this lab, we're going to connect to our Linux instance. So in the last lab, we launched two instances, one's Linux and one's Windows. And I launched mine into the Sydney region. Now, with the instance selected, if we go to Actions and choose Connect, we get some information here about how we can connect to the EC2 instance. Now, as you can see, there's the standalone SSH client, the EC2 Instance Connect, browser-based SSH connection, and a Java SSH client from the browser itself. Now, we're going to choose the standalone SSH client. Now, depending on your operating system, you may already have an SSH client installed, or you might have to use PuTTY. So for Windows, for instance, you'll often have to use the PuTTY tool, and we'll see how to do that a bit later on within this lab. Firstly though, what I'm going to do is connect using an SSH client on my computer. Now I'm using a Mac, so it already has an SSH client. And we can see that there are some commands here that we need to run. Now before we do that, I'm just going to show you what happens if you don't follow those instructions. So let's copy the public IP address to our clipboard. Now you will need your key pair, so my key pair file is actually here on my documents folder. Let's now go to the command line and try and connect to our instance. What I'm going to do is change directory to documents so I can see that my file is here, and I'm going to run the command ssh ec2-user at, and then I'm going to paste the public IP address. I then need to enter -i and specify the key pair file. If I now hit enter, I'm going to make a connection to the EC2 instance. However, we see that we have a problem. It says that our key pair file is unprotected. So this is because we didn't follow the instructions that we saw in the console. So if we go to Actions, Connect, we can see the commands we need to run. I'm going to copy this command, chmod 400 sydney-kp.pem, and just paste it in here. And if I run that and then try and reconnect, this time I'm in. So there's no problem. I've actually connected to the instance. If I wanted to, I could now run sudo su to get root access. I can run yum update -y to update my packages. You know, we now have full control of this system. The next thing I want to show you is how you connect using the PuTTY tool if you're a Windows user. Hi guys, I'm now going to show you how to connect to your Linux instance from a Windows machine. Now the Windows machine I'm using is actually an EC2 instance running in Singapore, but it doesn't matter where you're coming from. The point is that I want to show you how to connect from Windows using the tool PuTTY. Now I've already installed PuTTY, but all you need to do is just go to putty.org. You can find it by searching for PuTTY in Google, and you'll just choose one of these links, the 32 or the 64-bit installer. Once it's installed, we can then go to PuTTY-gen, and what we need to do is use this PuTTY key generator to modify our PEM file and generate a PPK file, which is what PuTTY actually uses. We choose load, we go to documents, and you won't see anything because it's looking for PPK files. So just choose all files, select your file and select open. Click OK and then save private key. And we'll OK that message, and we'll just call this Sydney-kp-win. And I'm going to save. And that's that done. We can close that one down. We can now go to PuTTY and just choose the PuTTY tool. And what you need now is your IP address. So let's go to the EC2 management console, and I'm going to copy this IP address to my clipboard. I'm going to come back and I need to type EC2-user at, because this is an Amazon Linux AMI, and then put the IP address on. I can now go down to SSH auth, and I need to load my PPK file. So I come here, I choose my file and select open, but don't click open again. Go up to the top, choose session, give your session a name. Let's call this my EC2-instance 2 because I already had one in here, and I'm going to choose save. I can now go to that option and select open, and that's it. We are now connected into our Amazon Linux instance running in Sydney from a Windows instance in Singapore. So that's just to show you how to access your Linux instances if you're using a Windows client for this course. In the next lab, we're going to connect to our Windows instance using an RDP client. Back in the AWS Management Console, we can actually terminate our Linux instance now, as we don't need this one anymore. We're going to use some new ones a bit later on in this section, but we can just terminate this instance. So to do that, select the instance, go to Actions, Instance State, and Terminate. And then you just choose Yes. And the warning here is just letting you know that by default, the EBS volume will be deleted along with the instance, which means you're going to lose all data on that volume. Of course, we don't have any data to worry about, so we can just choose Yes, Terminate. And that's it for this lab. I hope you're having fun, guys, and learning lots. In the next lab, we're going to connect to our Windows instance using RDP. We're now going to connect to our Windows instance. And the way we do that, if you just select your Windows instance here and go to Actions and Connect, you have a very different option to what you had before. So before we had a command line and we were going to use SSH, But in this case, what we're doing is we're connecting using RDP, and we need to get the password for our instance. So to do that, we can choose Get Password, and it asks us for the contents of our key pair. So that means we need to go to our key pair file that we downloaded, the PEM file, and actually copy that text. Now this is my file. I just put a .txt extension on it so I can open it more easily. And this is the contents of the file. Now bear in mind, this is very sensitive information. Anyone who has this will be able to connect to your instance, and as you've seen, they'll then have full control over those instances. So don't share this with anyone else. In my case, what I can do is actually just delete this key pair file and create a new one before I release the course, so it's not a problem for me. Coming back to the management console, we paste in our key pair contents and choose Decrypt Password. And we now get the password on the screen here. So you want to take a copy of that and paste it somewhere. What we can do now is take the public IP address of our instance, and we're going to connect to it using an RDP client. Now I'm running on a Mac, so I'm using this Microsoft Remote Desktop client for Mac. I can choose Add Desktop. I can put in the PC name as the IP of my instance. Click Add. We can then double click on this desktop, and we need to put in administrator as the username and then supply the password and choose Continue. And it's as simple as that. We're now getting logged into Windows on EC2. This is actually the only time I'm going to launch a Windows instance as part of this course. And the reason being is AWS is very Linux centric. So you really need to be competent at Linux to get anywhere in the AWS cloud. So I'm not going to concentrate on Windows anymore. Everything from here on is going to be Linux, but I just wanted to show you how you can access a Windows instance. Back in the AWS Management Console, we can now terminate this instance as we don't need it anymore. So I'm just going to go to Instance State, Terminate, choose Yes, and we now have that instance shutting down. So that's it for this very short lab, guys. I hope you had fun. And like I say, from now on, it's going to be Linux. I'm going to show you through all the commands that you need to run. So even if you don't come from a Linux background, it should be okay for you. See you in the next lab, guys. Hi guys, in this lab, I want to talk to you some more about security groups. As I've mentioned before, security groups are firewalls that are applied at the instance level. So they actually look for traffic that's going into and out of the elastic interfaces connected to your instance. You can have multiple instances in the same security group, and you can have multiple security groups applied to an instance. So what we see here is we have two instances, instance A and instance B, and they're both in the web access security group and the sec group A security group. Let's imagine that the sec group A security group enables ICMP ping. So that means that these instances can send ping packets to each other. A key fact about security groups is they're stateful, and that means if you allow an inbound connection, the response traffic is always allowed, and we'll see more about that soon. What we're going to do now is we're actually going to launch two instances, and we're going to set up this configuration. So let's head over to the AWS Management Console. So I'm in the EC2 Management Console, and I'm going to select Launch Instance, and I'm going to choose Amazon Linux 2 AMI. I'm going to choose the T2 Micro. I'm going to change to 2 instances, and they're going to go into my default VPC. I don't care which subnets they go in. It should spread them into 2 different subnets, and they're going to get public IP addresses. So that's all I need at the moment. And I'm going to choose the security group as web access. So that will give us the port 22 that we need to be able to secure shell into these instances. I just then go and choose launch, acknowledge, and launch instances. So those will take a couple of minutes to launch. So that took a few minutes, and they're both initializing, but they're both running, so I think I'll be able to connect to these now. So what I'm going to do is copy the IP address to my clipboard of one of them, and I'm going to head over and secure shell into that instance. And I'm in, so I'm going to clear my screen just to make things a bit clearer. And now I'm going to go and get the IP address of the second instance. So we now have a secure shell session to both instances. Now what I can do is I want to actually try and ping from one instance to the other instance. To do that, I'll need the private IP address, and you can either get that from the console here, or you can actually see it in the text here before our command line. So what I'm going to try and do is ping from this instance to the one on the right hand side. So I've put in its IP address, and let's try and ping. And it doesn't look like that's working. Let's stop the connection and we can see 100% packet loss. And let's try and do it the other way around. I'll ping 172.31.1.151 and hit enter. And exactly the same thing is going to happen. It's not going to happen because we don't have anything in our security groups that are allowing that connection. So let's go back, and what we're going to do is create a new security group. I'm going to click create security group, and I'm going to call this sec group A, and then I'm going to copy that and put it into the description. What I'm going to do is just save the security group, and I'm going to create a new security group as well, which we're going to be using shortly in this lab, and I'm going to call this one sec group B. And again, I'm just going to copy that and paste it in, and I'm not going to create any rules. And now what I want to do is I'm going to go back to sec group A, choose edit, and I'm going to add a rule, and I'm going to choose all ICMP v4, and I'm going to type SG, and I can see my security groups, so I'm going to choose the security group itself. So what that means is this rule will allow inbound traffic on ICMP protocol from the security group itself. So that means members of the security group. So any instance that's a member of this security group will be able to send ICMP data to other instances that are members of the security group, but no one else will. So I can choose save, and we can now go back up to our instances, and I'm going to choose each instance, go to networking, change security groups, and add in sec group A. We'll now go back to the command line and rerun those commands. So let's try and ping instance B, and that's working fine. And now let's try and ping instance A from instance B, and that's working fine as well. So that rule has allowed these instances to be able to send ping data to each other. Let's go back and swap instance B into sec group B. And now let's rerun those commands. So we'll try and ping again, and that doesn't work. And we'll try and ping again, and that doesn't work. So what we've done now is we've enabled this configuration. So we have instance A in sec group A and instance B in sec group B. The problem is sec group A is the only one that has a rule, and it only allows access from members of its own security group. So we need to change the rule sets now. So let's go back and see how we do that. What we need to do is go to security groups, go to sec group A, and instead we're going to pull that out and choose sec group B. So now we'll have inbound access on ICMP from sec group B. If we save that rule, we should find that we can now ping instance A from instance B, and that works fine. Notice how quick this is. The instant you change it, it takes effect. So security groups have immediate changes applied. Now the other way around, isn't working still. So we still can't ping instance B from instance A. So let's go back and change the other security group. So in this case, we need to change security group B and add a rule that allows ICMP v4 from security group A. And now let's go back and try that. So that's great, that's working. We can now ping in both directions. Now you'll notice that there's no return rules. If we go back to our security groups, in outbound, we already have a rule that says all traffic can go outbound, but we don't actually need that, because as long as the inbound rule allows the traffic inbound, the return traffic will go out regardless. We could actually go in here and remove that from both security groups. And let's go back and see if our ping works, and it still works in both directions. So security groups are stateful. The changes are applied immediately. You can specify inbound and outbound rules, and you can use your source or your destination can be a IP address, a CIDR block, or a security group. So there's a few things to understand, and we're actually going to be able to use these and put some of this into practice throughout this course. And this is really just a sort of starter, scratching the surface. We're going to get into a lot more detail later in the course. We don't actually need these security groups anymore, but they're attached to our instances. What we need to do is go and terminate our instances, which we don't need anymore. So I'm going to terminate both of these. And they're going to get shut down. And once that's done, we'll be able to go back and delete our security groups. However, you will run into a problem if you try and delete them now. As long as you have another security group referenced, you won't actually be able to delete it. So we can go to inbound rule, just delete that rule, do the same on the other security group, and save that. And now we should be able to delete the security groups. And now we should be able to delete the security groups. And they're both gone. And that's it for this lab, guys. I hope you're learning lots and enjoying the process. In the next lab, we're going to discuss instance metadata. Hi guys, in this lab we're going to talk about instance metadata. So there's instance metadata and instance user data, and user data will be the next lab. So for now I'm going to talk about metadata. Instance metadata is data about your instance that you can use to configure or manage the running instance. And this is an article that will be in the course download, which describes a bit more about it. But the best thing to do is to show you it in action. Now you can see some commands here on the screen, and we're actually going to run these commands. So I'm just going to copy this one to my clipboard. In fact, what I need is this one here, because this has the curl command. So you can go there, you can choose the option here just to copy it to your clipboard. And what I've done is I've actually launched an instance. It's just a T2 Micro Amazon Linux 2 AMI. And what I'm going to do now is head over to the console. So I'm logged into my instance, and if I run this command, we're going to see some information. Now, you definitely need to know this command. So just remember that the URL is 169.254, and then it repeats .169.254, then it's /latest/meta-data, and you do need that trailing slash. If you take it off, nothing happens. If I put it on, this is what I get. So this gives me some categories of information about my instance, and I can then drill down further into this. So for instance, I could put on public-hostname, and what happens is the public hostname gets prepended to the text here, so you can actually see the hostname of the instance. I could do the same for public, let's put in -IPv4, and again you get the public IP address. And you could do local hostname, so let's just type in local-hostname, and again you get the hostname. You could get the instance ID, you can get metrics and information about the network and so on. So there's lots of information there that you can use. I'm going to clear my screen, and I want to show you one more tool. The tool I want to show you can be downloaded by running wget with this URL, and this will be available again in the course download. If I press enter, it downloads the file, and if I now do ls, I can see that I have this file. If I do an ls/la EC2 -metadata, however, I can see that I don't have executable permissions. So I'm going to do chmod u plus x EC2 metadata, and now I should have executable permissions. So I can actually run this tool. And let's put in the -help option, and you can see a help menu here. And what you can then do is choose one of these options. So for instance, let's put -p for public hostname, and it retrieves that information. And then we could do -z for availability zone, and it shows us which availability zone we're actually in. So this is a better way of accessing the metadata at the command line like this. However, the URL is very good for working programmatically with instance metadata. So that's just a really quick lab just to show you what instance metadata is. You should remember the URL, which is http://169.254.169.254/latest/meta-data with a slash on the end. That's it for this lab, guys. In the next lab, we're going to go through EC2 instance user data. We're now going to discuss instance user data. So we discussed metadata before. On the same article, you can see user data if you just scroll down a bit further. And what instance data actually is it's information that you can pass into the instance as it boots. So for instance, you can run some commands as the instance boots and configure your system. So we're going to head over to the management console and actually launch an instance and see this in action. So we're going to choose launch instance, choose the Amazon Linux 2 AMI and the T2 micro instance type. And then we're going to leave all the defaults, but we're going to go down to advanced details here, and this is where we put in our user data. So I have mine on my clipboard. What I have is the path to my interpreter, then yum update -y to update packages. Then I'm going to install the HTTP daemon. Then I'm going to start it and enable it, so I'll have a web server at this point. I'll then change into the HTML directory and create a page that has this text on it, which we should then be able to connect to on port 80. We can then choose next, next again, and configure security group. Now, under select an existing security group, I have my web access security group, and I've actually already added port 80 into it. If you haven't got that, you need to just go into your security group and add 80 inbound. We can then choose review and launch. It's been a couple of minutes and my instance is running. It's still initializing, but let's see if we can connect to the web server. So I'm going to choose copy to clipboard to get the IP address, and then I'm going to put in the IP address into my browser, and there we go. We've got the text which we're expecting, saying this is a test page running on Apache on EC2 in the AWS Cloud. So that's awesome. So with user data, we can pass this information in and configure our system, run commands as it boots up. We can also run a command on the instance to actually see the information that's configured in the user data. I'm logged on to my instance and I can just run curl and then put in this IP address. So it's very similar to the metadata we covered in the previous lab, except it's HTTP 169.254.169.254/latest/user data, and you don't need the trailing slash. And in this case, you can see the information that's stored in the user data. So that's really it. We're going to use user data quite a lot throughout this course because we're going to configure web servers and various other configurations quite a few times. So you'll see this over and over again. That's it for now, guys. See you in the next lab. Hi guys. In this lab, we're going to look at EC2 status checks and monitoring. We still have an instance running from the previous lab, and I'm looking at the status checks. If you don't have an instance running, just install an instance And what I want you to do is make sure you choose the Amazon Linux 2 AMI and obviously the T2 micro so it stays within the free tier. And just put it in your web access security group so you have secure shell access to it. And that's all you need to do. So when you have an instance running, you'll see that you have some status checks here. These are EC2 status checks and they're performed every minute and either return a pass or a fail status. If all the checks pass, the overall status of the instance is okay. However, if one or more checks fail, the overall status is set to impaired. We have system status checks and instance status checks. System status checks are for problems with your instance that require AWS involvement to repair. So that's a good way to remember it. Just think when it's a system status problem, it's related to something that AWS needs to troubleshoot. With instance status checks, this is more about problems that involve the operating system and therefore you need to work on it. You can't enable or disable status checks, but you can create or delete alarms that are triggered based on the result of status checks, and that's something we're going to look at shortly. If we go to the monitoring tab, and I'm just going to pull this up so we can see a bit more information here, we can see that we have CloudWatch alarms. Now CloudWatch is a service used for monitoring, so it reports operational information using metrics that are collected from services within AWS. And you can see we have no alarms configured here. We're going to create one shortly. Now there's two different types. You have basic monitoring, which means every 5 minutes, and you have detailed monitoring, which is every 1 minute. If you enable detailed monitoring, you do have to pay for it. So as you can see, you can enable it for the instance and it will change to 1 minute frequency of metric collection. I don't need to enable that for this lab. So what we're going to do is we're going to enable an alarm that triggers when our CPU utilization reaches a certain threshold. You can see there are quite a few metrics in here that you could use. But what I want to do is choose create alarm. And what I'm going to do, rather than sending a notification, I'm going to take an action. And what I'm going to do is terminate the instance. And it's going to do that when the average of CPU utilization is greater than or equal to 80% for at least one consecutive period of 5 minutes. And I'm just going to leave the default name for the alarm and choose create alarm. So now what will happen is if our utilization of the CPU hits 80% or more, the instance is going to be shut down and terminated by AWS. And that's because we have an alarm that will be triggered with an action that says to terminate the instance. So what we want to do now is actually trigger this alarm. And I'm going to head over to the command line to do that. I'm on the command line of my instance and I need to run this command. And this installs some repositories from where we can get the stress tool, which I'm going to use. I'm then going to run sudo yum install stress-y. And that's installed the stress tool. And I can now clear my screen. So what this will do is it will actually generate stress on the CPU. If you just put in -help, or is it 2 dashes -help maybe? Yeah, there we go. So we've got a series of command line options that we can apply. What I'm going to do is run stress-c8. And what the C command does is it spawns a certain amount of workers. And I'm going to choose 8, and that's going to generate quite a lot of load on the CPU. So let's hit enter, and that's going to start. And we can go back to our console and watch what's happening. Now you can always choose here and you can see what's going on, but it's going to take a bit of time because we only have basic CloudWatch monitoring at this stage. So it's only going to pick it up every 5 minutes. So it'll be a few minutes before it realizes that the CPU is heavily loaded, and then it might be another few minutes before it then sees that it's still in that state and terminates the instance. While we're waiting for that to occur, we can just have a look into the CloudWatch alarms here, and if we choose View More Options, it opens the CloudWatch Management Console. And so in here you can see a bit more detail, and you can see that our alarm is in the status of OK, so there's nothing wrong at this stage. CloudWatch isn't aware of there being any heavy load on the CPU. Back in EC2, we can see that our CPU load has gone way up now. According to this, it's not quite 80, but I think it probably is, and we'll see with the next metric whether it has exceeded that threshold and caused the alarm to be triggered. So a few more minutes have gone past, and we can now see that another metric has come in and it's hit 100% CPU, so we should soon see that our alarm gets triggered. Let's head over to CloudWatch and have a look, and sure enough, we're no longer OK. We've now gone to a red 1 to say that we're in an alarm state. So let's go back and see what happens to our instance, and sure enough, there you go, it's been terminated, and you can see here that it's an alarm that caused that termination. So that's just taught you a little bit about monitoring and status checks, and also CloudWatch and how you can create alarms that trigger on certain events that are happening to your resources. So I hope that was a fun lab for you, and what we're going to do in the next lab is we're going to have a session on public, private and elastic IP addresses. Hi guys, we've got a couple of labs now on public, private and elastic IP addresses. Now it can be a bit of a dry subject, and so I'm going to break it up into 2 or 3 labs, and this one is really going to be a lesson. So I'm just going to talk to you about some of the theory now, and then we're going to get into some examples and I'm going to show you the behavior of the addresses. So let's get started with a bit of theory. So as you know, we have public IP addresses, private IP addresses, and also elastic IP addresses. So a couple of facts about them. A public IP address is lost when the instance is stopped. So if you run your instance and you reboot it, it will retain its public IP address. But if you stop the instance and then start it again, it actually picks up a new one because these are dynamic public IP addresses. Obviously you use them in public subnets and you don't actually pay for their usage, so it's a free address that you get from Amazon. Public and elastic IP addresses are both associated to a private IP address on the instance, and I'm going to show you a diagram and explain this concept to you a bit further in a second. With private IP addresses, the address is retained when the instance is stopped, and your instance will have a private IP address whether it's in a public or a private subnet. And like I say, that's because the private IP address is actually what the operating system sees. So the public or elastic IP address is associated to that address. We'll see this a bit further in a second. We then have the elastic IP addresses. So this is a static public IP address. Now what you have to do is request the address, and then you can associate it with an instance. If it's not used, so it's disassociated or the instance is stopped, you do get a charge for it. So you're not actually charged if you're using it, but you're incentivized to actually make sure you're using it, and you're charged if you don't. So let's have a look at a couple of diagrams to understand these concepts a bit further. In this diagram, we have an EC2 instance. So this box here is an EC2 instance. Let's say it's running Linux, but it really doesn't matter. The instance has 2 Ethernet interfaces. Both of them have a private IP address, but one of them, the primary interface, ETH0, has a public IP address associated with it. Now this could be a public or an elastic, so either a dynamic or a static address. It doesn't matter. The point is, this is outside of the operating system. The Linux operating system doesn't know anything about this address. All it knows is this address. However, AWS map this address to this one, and that's actually performed over the Internet Gateway. So the Internet Gateway performs one-to-one network address translation. And what that means is, when data comes into this public IP address, the Internet Gateway will then swap that address from the public IP address to the private IP address. so that the operating system can then pick it up and process that data. When data goes outbound, the source address from the operating system's perspective would be the private IP address, but to make it routable on the internet gateway then needs to translate the source address to the public IP address of the instance. And now that data can go out with a source address that's actually relevant on the internet. So that's just a bit of theory. And what we're going to do in the next lab is we're actually going to run through a couple of scenarios with private, public, and elastic IP addresses to see how they work and how they behave. Hi guys, so carrying on from the last lab, we're going to just have a quick look at private IP addresses now before we go on to learn about public IP addresses a bit more. So all I wanted to show you is I've launched an instance, and the instance, as we can see in the console here, has a public address, but it has a private address here. So every instance will have a private address, whether it's in a public subnet or a private subnet, it doesn't matter. It's always going to have one, and the address is going to be from the range assigned to our VPC and the subnet which we launched this one into. So if we head over to VPC, and this subnet is assigned to availability zone AP Southeast 2A, and we can see it has a CIDR block of 172.31.0.0/20, and that's where our EC2 instance is. So we can see that this instance is in AP Southeast 2A, and therefore our address is within that CIDR block range. You can also see there's a private DNS address, which, just like the public DNS address, contains the actual IP address within the first section here. Now I've logged onto this instance, and I just want to show you what the operating system sees. Now remember, this has a public IP address and a private IP address. So I'm logged onto the console for the EC2 instance, and let's run the command ifconfig. And this shows us our local interfaces, and we only have one interface, eth0, and we can see that it has an IP address, and that's the private IP address. So there's absolutely no sign of the public IP address here. That's because the operating system is not aware of it at all. So there's nothing about the public IP address on the instance. The public IP address is external to the operating system, and AWS takes care of the association between that address and the private address. If we go back to our instance, let's just have a quick look at the behavior. What I'm going to do is I'm going to shut down my instance. And so just make sure you remember the address. It's 172.31.4.192, and we'll stop our instance. So the instance is stopped, and in fact we didn't need to remember anything because we can see that the private IP address is still here, but the public IP address is gone. So when you stop the instance, you do retain this private IP address, but you lose your public address. And if we start this instance back up again, we're actually going to get a completely different public IP address. Just going back to the slide, so that just reinforces what we knew here, that we have private IP addresses in public and private subnets, and the private addresses are retained when the instance is stopped. And this is all the operating system sees. It doesn't see the public IP addresses, and it doesn't see the elastic IP addresses either. So that's it for this lab. In the next lab, we're going to cover the public and elastic IP addresses in more detail. Hi guys, we're now going to cover the difference between public IP addresses and elastic IP addresses. So I've got a bit of theory to cover, and then we're going to go into the console and see how all this works. So the terminology can be a little bit confusing because both a public IP address and an elastic IP address are public IP addresses. So they're always IP addresses that are publicly routable on the internet. The key difference is that the elastic IP address is static, whereas the public IP address is dynamic. So if you put your EC2 instance into a public subnet that's configured to provide that instance with a public IP address at boot time, it's going to be a dynamic public IP address. And that means that when you stop the instance, you will lose the address. If you restart the instance, you don't lose it, you retain the public IP address. But every time you stop the instance, you're going to lose it and you're going to pick up a new one. So you don't always want that. That might not be ideal in many situations. With an elastic IP address, it's static. So you can stop your instance and start it again. You can reboot it. You can do whatever you want. And you'll always have the same public IP address. The other key difference is you can move an elastic IP address between instances and elastic network adapters. Elastic network adapters are just additional interfaces that you can attach to your instance, and we'll see those in the console shortly. With a public IP address, there is no charge, and these are used in public subnets. With an elastic IP address, you are charged if the IP address is not used. So for instance, you might have allocated an elastic IP address to your account, but you haven't associated it with an instance or an elastic network adapter. Alternatively, it might be attached to an instance, but the instance isn't running. So in those cases, you actually have to pay a small charge, which is really AWS trying to incentivize you to use these addresses because IPv4 addresses are in shortage on the internet. So the other thing about public IPs and elastic IPs is they're always associated with a private IP address on the instance. So let's go back to this diagram I showed you earlier. You remember that from the Linux operating system, or Windows, whichever way, you will only ever see the private IP address because the public IP address is associated to it, but it's external to the operating system. So every time you allocate a public IP address, it must be associated to a private IP address. Now, when you boot your EC2 instance into a public subnet, it will have a private IP on ETH0, and it will automatically associate a public IP, which is associated then with ETH0. Alternatively, you can add an additional elastic network adapter, and that could be ETH1. And you can then choose to associate an elastic IP address to ETH1. And we'll see how all this works shortly. Now you'll remember that your internet gateway is your path out to the internet. And it performs one-to-one NAT. So it actually takes your source address and changes it to the public IP address. So your source address from your operating system, when it sends a packet out onto the network, is always going to be the private IP because that's the only IP it knows about. The internet gateway's job is to then change that to a public address and send it out to the internet. And that way it can be addressed and routable on the internet. And then in the reverse, when it receives packets that need to be sent to your operating system, it needs to change the destination address to this address because it can't be received on the public address, because your operating system's not aware of it. So that's how that works. And if you see on this slide here, again, you can have ETH1 can have a public IP address or an elastic IP address associated with it. And in that case, there is still a private IP to public IP association. So it's the same thing. So let's head over to the console now and see all of this stuff in action. So I'm in the EC2 dashboard, and what I'm going to do is just run up an instance. So I'm going to launch a Amazon Linux 2 AMI. I'm going to use the T2 micro, and I'm just going to leave all the defaults here. I don't need to change anything. It's going to go into my default VPC. All I want to do is just change my security group. I just use my web access security group. I'm not even going to SSH into this, but I just need to choose a security group anyway. And then we just hit launch. So straight away we can see that a public IP address has been associated with this instance, and that happens straight away. And then here's the private IP address. So the private IP address and the public IP address will be associated. And as you know from the previous lab, if I did SSH into this instance, you wouldn't see this public IP address. Now let's go down to network interfaces. You can see we only have one. And if we click on that interface, it gives us some information. So we can see stuff like the interface ID, the VPC that it's in, and you can see the private IP address and the private DNS name, and then the public IP address is all here. So I'm just going to let this initialize and pause the recording for a second, and then let's see what happens when we restart or stop our instance. So this instance is almost ready. Now, one of the things you can do to see the status of the instance is go to Instance Settings here under the Actions menu and Get Instance Screenshot. And here I can see that the operating system is booted and it's ready to be logged into. But I'm not actually going to log into it. I just wanted to have a look. Now, the status checks haven't completed yet, but the operating system is running. So we've got our public IP, and it begins in 13 and ends in 91. So let's keep an eye on that. And then what I'm going to do is just restart the instance. I'm going to choose reboot. And now that it's booting, I can go back to instance settings, get instant screenshot, and as you can see, we get an error getting console screenshot message. So that means that it's actually in the process of rebooting, and we'll just wait a couple of minutes until it's back up again. Let's have a look again and see what the status of this operating system is. So it's booting up, it's on the way, and let's just click close there. But the thing that we can see is that even if we hit refresh, we can see that we still have the same IP address that ends in 91. So that's what happens when you reboot. But what happens if we want to shut down? So in that case, I can go instance state stop and choose yes. And so the instance is stopping now. And in a minute, once it's in the stop state, we should see that the public IP address disappears. So there we go. The instance state is stopped, and we can see that the public IP is gone. The private IP address is still there. So that's something to remember. Your private IP address is retained when you stop your instance. Let's start it up again and see if it gets a new address. So the instance is starting up and it's actually in the running state now, and you can see it's got a new public IP address. Now the private IP address is the same, and we now have an association with this new public IP address. So that's what happens when you stop and start an instance. So that's it for this lab, guys. What I'm going to do is stop it here, and then I'm going to start a new lab, and in that lab we're going to go through elastic IP addresses. Hi guys, and welcome back. We're now going to continue with a discussion on elastic IP addresses. I've launched two instances into my VPC. Now all I've done is put them both in the same subnet, so they're both in the same availability zone here, and I just used an Amazon Linux 2 AMI and T2 micro instances, and that's really all you need to do. So both of these are in a public subnet, and therefore they have a public IP address. Now as you know, these are just the dynamic public IP addresses that instances pick up when their subnet is configured to provide them with one. What we want to do now is actually create an elastic IP address and associate that with an instance. So you come down to elastic IPs here under network and security and choose allocate new address. And the scope is VPC, and that really is it. There's nothing else to do. You just choose allocate. And as you can see, we now have a public IP address. And this is going to be a static address. So if we close, we can come back here, we can see we have this allocated to our account, and it's not going anywhere. It's not even associated with an instance or a network adapter. So what I want to do now is actually associate it with my instance. So I choose Actions, Associate Address, and under here you can choose two different types of resource. Either an EC2 instance or a network interface. So that's an elastic network interface, and we'll see how to create one of those shortly. I'm going to choose instance, I'm going to choose instance 1, and then I have to associate it with the private IP address. So that means it's going to disassociate the existing public address. So it warns you here by saying if you associate an elastic IP with your instance, your current public address is released. So the dynamic address is released and the new elastic or static address is assigned. So I'm going to choose associate. Before I do that, I'm just going to choose learn more. I just want to bring this article to your attention. If you scroll down a little way, you can see some information about the behavior of public IPs. It says here that AWS will release your instance's public address when the instance is stopped or terminated. We know that from the previous lab. It also says we release your instance's public address when you associate an elastic IP address. So that's what we're doing now. And then if you disassociate the elastic address, the instance will pick up a public IP. However, if your instance has more than one network interface, it won't pick up a new dynamic public IP address. And also, if your instance has a secondary private IP address with an elastic IP associated with it, it also won't pick up a new dynamic public address. So those are just a few things to understand. Let's close that and choose associate. So we now have our address associated. Let's go back to instances, choose instance 1, and we can see now here under elastic IPs we have an address. And that address now shows as the primary IPv4 public address. We still have only one Ethernet interface, ETH0, and if we choose that we can see that we have the public address and the private IP address. So very simple. And now if we stopped our instance and started it again, it would retain that IP address. The other way you can associate an elastic IP is using an elastic network interface. So let's first go to elastic IP addresses and allocate another one to our account. So we have this second address here. Let's go to network interfaces. And what you can see here are the elastic network interfaces associated with your existing EC2 instances. So these are the ETH0 interface on those instances. I'm going to create a new one. I'm just going to call it my ENI. I'm going to choose my AP Southeast 2A availability zone so that I'm in the same subnet. And then you can choose custom or auto assign for IPv4. I'm going to leave it on auto assign. And then we're just going to choose a security group. Now, just a note, the Elastic Fabric adapter here, if you choose the information icon, it tells you that this is a device used for reducing latency and increasing throughput for HPC, high performance computing, and machine learning applications. So those are for specific use cases. We don't need those now. Let's just choose create. And what I'm going to do to make sure this is clear in the console, I'm going to put the name here as well, so my ENI, and just OK that. And now if we come back to Elastic IPs, I'm going to go to Actions, Associate Address, choose Network Interface. I can find my address, I can find my network interface, and then I can associate with a private IP address. And let's click Associate. So we now have an Elastic Network adapter, and it has a public IP, and its status is available, so it's not in use. What we need to do is assign it to an instance. So we do that by clicking Attach, and we choose our instance 1 and Attach. If we now head back to instances, under instance 1, we can see we have 2 Elastic IP addresses and 2 network interfaces. So you can see the new Elastic IP is associated with ETH1. Now remember, one of the key benefits of Elastic IP addresses is they can be reassociated. And it's the same for Elastic network interfaces. So you can't move ETH0 to another instance, and you can't move a public IP to another instance. But you can move your Elastic IPs and your additional Elastic network interfaces. So if I go down to network interfaces, I can choose to detach my interface. I'll choose force to make sure it works. And now that it's detached, I can attach it and choose instance 2. Now remember, in the real world, you might want to do this programmatically, and that means that you can then fail over your address to another instance. Maybe that's something that you programmatically use for failure scenarios, or you might move an Elastic Network interface because of replatforming or something like that. So let's go back to instances, and if we choose instance 2, we can now see that it has ETH1 with the same public IP address. So I've just moved that interface onto a different instance. Now, if you can imagine that you have a public DNS name that's resolving to the IP on that network interface, it would now be directed to instance 2 rather than instance 1, and you could easily remap it to a third instance if instance 2 failed. So that's just a little bit about Elastic IPs. What I'm going to do now is terminate my instances, and remember, this is really important now, that you need to release your Elastic IPs because you do get charged for Elastic IP addresses when they're not in use. Now you have to wait until your instance is shut down, because as long as they're associated with an adapter that is in use, you won't be able to release them. But that should just take a few seconds, and then we'll go into Elastic IPs and release our addresses. So both of my instances are terminated. Let's go to Elastic IPs, and I'm going to choose to release this address, and I can see that this other one is associated with a network interface. That's my Elastic network interface, so I need to disassociate it first, and then I can release the address, and now you won't get charged. And we can go in and delete our Elastic network interface as well. So that's it for this lab, guys. In the next lab, we're going to cover private subnets and bastion hosts. Hi guys, up until now we've been using public subnets, which as you know means that your EC2 instances are accessible from the internet. As long as you have the right security group rules, you can access them over Secure Shell or Port 80 or whatever it is that you open up. So obviously that's not ideal for many scenarios. You want to keep your servers internal in a private subnet that don't have direct access to the internet. And that's what we call a private subnet. So the key difference with a private subnet is that it doesn't have an internet gateway in its route table. So remember, every subnet must be associated with a route table. Now, a public subnet has a route table that has two entries at a minimum. So firstly, you have this route, which is the CIDR block for your VPC. And what that means is that all traffic to any subnets that are within this CIDR block are routed locally. So that enables routing between subnets, between public, private subnets, across multiple availability zones. It doesn't matter. Everything within that CIDR block is going to get routed locally by the VPC router. The other entry in the route table is going to be the entry to the Internet Gateway ID. So in this case, you normally put 0.0.0.0/0, which means any destination, in other words, any other destination, anything that isn't within this block, send it to the Internet Gateway. So any address within this block, route it locally. Any other address outside of that, route it to the Internet Gateway, and it can go out to the outside world. A private subnet route table doesn't have the Internet Gateway route, so it doesn't have a route to the outside world. Also, it's not configured to provide public IP addresses to the instances that are launched into it. So if we launch an EC2 instance into a private subnet, it gets a private IP. There is no public IP, and therefore there's no way to access it directly if you're trying to manage your instance from the internet. So one of the ways around this is you use what's called a bastion host. A bastion host is literally an instance in a public subnet that you use to then jump to your private subnet. So it's also called a jump host, so either a bastion host or a jump host. I think in AWS terminology it's usually bastion host, but many people call them jump hosts. So what you do is, for instance, in this case, these might be Linux instances, and you use Secure Shell, and you SSH into this EC2 instance, you get a command line, and then from there you SSH into this one. And now you can manage your instance in your private subnet from the internet or from some other network. So that's the theory, and we're actually going to create this configuration in the lab now. So we're going to create an EC2 instance in a public subnet. We're going to create an EC2 instance in a private subnet. Now we don't actually have any private subnets yet, so that's going to be the first task, is to go into the VPC management console and create ourselves a couple of private subnets. So I'm on the AWS management console in the VPC dashboard. And what I'm going to do first is I'm going to create a new route table. So just to show you what we have at the moment, we just have our default VPC. We just have 3 subnets, the default subnets that are created with our account, and those are all public subnets. And you can see that because they have default subnet here and auto assign public IP here. So we know they're default subnets, and they're going to assign public IP addresses to instances that are launched into them. Now under route tables, we just have a single route table, and that has the route to our CIDR block local and the route to the outside world via an internet gateway. And you can see under subnet associations which subnets are associated with it. And at the moment we have just these 3. Now bear in mind guys, I'm taking you straight into the virtual private cloud here, despite the fact that we haven't actually covered that in the course yet. Now the reason is I'm going to show you bits and pieces along the way so that you can build your skill set. And then when we get to the VPC section of the course, we're going to do more of a deep dive. And you'll already understand the foundations, so it'll be much more easy for you. So let's go back to route tables, and I'm going to create my second route table. And I'm going to call this RT1. And you associate that to a VPC. We only have one option. I choose create, and that's all I need to do. So it will have a route to the CIDR block of our VPC. It doesn't have any subnet associations yet. There's none in the list here. And what we want to do now is create our subnets. So I'm going to choose create subnet. I'm going to call this one private subnet 1, choose the VPC. I'm going to put this one, associate this to an availability zone AP Southeast 2A. So each subnet can be associated with one and only one availability zone. So it's a one-to-one relationship. And you then have to choose the CIDR block. So how do we work out what IP address range to use here? Well, let's just open another tab. I'm going to open the VPC management console in a second tab here. And what I'm going to do is just have a look at the subnet ranges that we've got. So what we have here is 172.31.0, and then it's a .32. Sorry, then it's a .16, and then it's a .32. So I suspect the next one is going to be .48, but I can easily put this into a subnet calculator to work this out. So to do that, we can go over to Google and search for IP subnet calculator. And I like to use this one, IP subnet calculator, which is on calculator.net. So what I need to do is put in my range here. So let's take this address here, and we know it's a /20. So I'll just copy that to my clipboard, put that in, and then change here to /20 and choose calculate. And if we scroll down here, what we can see is the network address ranges. So we've got 172.31.0, then .16, then .32, then .48. So what I'm going to do is choose this one, .48, for my first subnet. So let's come back to the VPC management console. I'm going to paste this in, put .0 and then /20 for the subnet mask, and choose create. So that's subnet 1, and we can then do the same again. I could just call it private subnet 2, choose my VPC, choose to put this into B, and then what's my next range? So the next one is 64. So I'm going to copy that to my clipboard, paste that in, .0 and then /20. Got 2 dots in there, let's get rid of that one, and create. So now we've got 2 private subnets, and we could keep doing that. We could do that for the third availability zone if we want. I don't need those, so I'm just going to leave it there. But what we do need to do now is go to route tables, and under route table, we need to choose subnet associations, and we need to find our subnets and associate them. So we choose edit subnet associations, and I can choose these 2 new subnets, the .48 and the .64. And you can see they're currently associated with the main route table, which is what happens by default when you create a subnet. Let's choose save. So we now have our private subnets that are associated with a route table. So what we have is 2 private subnets, and the only thing they have in their route table is this CIDR block for the local VPC. So what we want to do now is actually go and launch our public instance and an instance into our private subnet as well. So I'm in EC2. I'm going to launch an instance. So it's going to be an Amazon Linux 2 AMI, T2 micro as always, and I'm going to choose my public subnet 2A. Choose next and just go to our security group, and we need to give this web access. So again, that's for SSH. We will be using the SSH protocol to connect into this instance. And now I can choose launch. So that's one done. Let's do the other one. So the other one, it's going to be the same, except we're going to put it into one of our private subnets. So let's just put it into private subnet 1. And again, we're going to need to SSH into this one. So we need to use our web access security group. And that's it. We've got our instances launching. So let's grab the public IP address of our instance in the public subnet. And we're going to use SSH to connect into it. And so I'm going to use my public key file, and let's connect in. So that's great. So we're connected into that instance in the public subnet. So now we want to be able to connect from this instance to the instance in our private subnet. Now the question is, as you know, we've just connected by running a command and specifying our key pair file. So as you know, the key pair file is security sensitive because it allows people to access your EC2 instances and gain root level administrative permissions. So how do you connect from your public instance to your private instance? Because we've used a key pair file which we've stored securely on our client, but we don't have that key pair file on here. So let's just go back and see what happens if we try to connect. And the instance in the private subnet is only going to have a private IP address. So let's copy that and let's go SSH EC2-user at and give it the private IP address. And let's choose yes. And of course we get a permission denied public key. So we can't do that. We need to be able to connect using a key pair file. So what we have to do is we just got to lose that connection, and I'm going to clear the screen to make things easier. And I need to run a command, and that is ssh-add. And then if you're on Linux, you do -c. I'm on a Mac, so I do -K. And then we specify the key pair file. And it says that the identity has been added. And that means that we can now connect without having to specify the key pair file. But also, we can configure agent forwarding. So you do ssh-a, and that's a capital A. And then you do EC2-user at, and then let's just go back to the console, and we're going to need the public IP of our public instance, and we connect. So we're connected into that instance now, and what we can do this time is let's just go back and get the private IP address of our private instance, and now we should be able to SSH to the private IP address, and there we are, we're actually in. So that's how you do agent forwarding, and that allows you to be able to connect from your Bastion host to your instance in a private subnet. So just to summarize what we've done, we've created a private subnet, which is a subnet in which instances do not pick up public IP addresses, and they have a route table that doesn't have a route to the outside world via an internet gateway. We've then created a Bastion host, which is a jump host in our public subnet, and we've used that to connect using agent forwarding for our key pair to an instance in the private subnet, so we can now manage that instance. So that's really cool, guys. One of the things that you might have noticed is though we're able to connect to the outside world from our public subnets going outbound, we can't do that from our private subnet because we don't have an internet gateway. So if we go back to the console and I just do ping google.com, it's just going to fail, and we're going to see that we got 100% packet loss. So we don't have a path to the outside world, and that's going to be the subject of the next couple of labs where we're going to look at how we can do that. And there's two ways. One is called a NAT Instance, and one is called a NAT Gateway, and we're going to cover both of those in detail. See you there, guys. Hi guys, in the last lab I introduced private subnets to you, and we deployed an EC2 instance into a private subnet, and then we saw how we could use a Bastion host to access it. But one of the problems I mentioned at the end is your instance in the private subnet doesn't have any way of accessing the internet. So you can't get updates, you can't connect to applications on the internet, you are basically isolated, which for some use cases is fine, but for many it isn't. So you need to be able to connect your instances in private subnets to the internet. And there's two principal ways that we do this, and these are the two that are likely to come up on the exam. So one is called a NAT Instance. NAT stands for Network Address Translation, which really is the process of taking a private IP address and translating it to a public address so that you can speak on the internet. The other is a NAT Gateway, which is a bit newer than a NAT Instance. So I'm just going to explore both of these with you now in a theory lesson, and then we're going to go on to a couple of labs where we put these into action and you see how they work. So I'm actually going to start with just going through this table. A NAT instance, so this is the old way. What you actually do with a NAT instance is provision an EC2 instance and then configure it so that it performs the network address translation. So you actually launch that EC2 instance and therefore you must manage it. With a NAT Gateway, it's actually managed by AWS. So all you have to do is create and attach a NAT Gateway, and everything else is done by Amazon. With a NAT instance, the only way to scale it is by scaling the instance type. So in other words, using a bigger instance type with more resources and perhaps enhanced networking to get additional bandwidth. With a NAT Gateway, it elastically scales up to 45 gigabits per second. So that's quite a lot of bandwidth. With a NAT instance, there's no high availability. You'd have to script it using auto scaling or something like that, using NATs in multiple subnets. So there's no native way to do it. It's not easy. It's a bit messy. With NAT gateways, you get automatic HA within an availability zone, and you can place a NAT gateway into multiple AZs. With a NAT instance, you have to manage security groups. With a NAT gateway, you don't. Some of the advantages of NAT instances are you can also use them as a bastion host. So maybe that's an advantage. I would just deploy a separate bastion host, so it's not really a big one. But with NAT gateways, you can't actually access them through SSH at all. With a NAT instance, you can use an elastic IP or a public IP. With a NAT gateway, you choose an elastic IP to associate with the NAT gateway. One of the other potential advantages of a NAT instance is you can implement port forwarding through manual customization. NAT gateways don't support port forwarding, so potentially that could be an issue. In most cases, it won't be. So let's just have a look at a couple of diagrams before we head into the labs. So this is a NAT gateway. It's a device managed by AWS. You provision it into your availability zone or into your subnet, and then your EC2 instances and private subnets are pointed to the NAT gateway through the route table. So you remember the route table for a private subnet doesn't have an internet gateway, but in this case it has a NAT gateway ID. So your route to the outside world, that IP address range that says anything that isn't within this range, the CIDR block range for the VPC, will be routed via the NAT gateway. So it goes out to the outside world. With a NAT instance, it's just an EC2 instance that you manage, but essentially it's the same thing. So from the route table's perspective, you configure it and you put in your NAT instance ID instead of a NAT gateway ID. So that's the theory, guys. Let's get stuck into some labs and create these configurations. Hi guys, in this lab we're going to create a NAT gateway and we're going to create a EC2 instance in a private subnet, and we're going to see how we can use the NAT gateway to access the internet. Now, one of the things you may have noticed when we showed this slide in the last lab is that the NAT gateway is in a public subnet. So to get the elastic IP that it needs to access the internet, it must be in a public subnet. So that's a key thing to make sure you get right. Let's head over to the console and create this configuration. So I'm in the VPC dashboard, and what I'm going to do is go down to NAT gateways, choose create NAT gateway, and I'm going to choose my subnet. So as I mentioned, you want to put this into a public subnet. So these three here are definitely public subnets, so I'm just going to choose one of these. And then it asks for an elastic IP. Now we don't have one allocated to our account. If we did, we could just choose it here. Instead, we're just going to create a new elastic IP and create a NAT gateway. And that's it. You can now see that we have the NAT gateway ID. So that's awesome. That's what we're going to use in our route table. Let's click close, and we can see that the status is pending. So it will take a few minutes to actually get this up to a status where we can actually use it. And while that's happening, let's go and configure our route table. So what I want to do is go to my route table here, RT1. So this is the one that's associated with my private subnets. So these two guys here are my private subnets, private subnet 1 and 2. And what I want to do is go to routes, edit routes, add route, and I'm going to provide the 0.0.0.0/0, which basically means any address. So as I mentioned before, you have your CIDR block, which is routed locally using the VPC router, and this address range says that for any other IP address, if the destination is any other IP address not within this CIDR block, send it to, and we can choose the NAT gateway, and it's going to send it to the NAT gateway. And that's all we need to do. We can click Save Routes. So that's done. Let's head over to the EC2 management console. So I'm just going to open this in another tab. Head into here, and I'm going to choose Create Instance. Now I terminated my instances from the previous lab, so let's just choose to create a new one, and I'm going to put this into my private subnet 1. Choose Next, 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 and let's just give it the web access, and review and launch. So that instance is launching. Now, of course, we need to be able to connect to that instance. So I am going to still need an instance in a public subnet. If you left your instances running from the previous lab, you should be able to use those. But all I'm going to do is make sure this one goes into a public subnet. Click through, choose select existing security group and web access, and then launch. So just going back to this diagram, what we've done is we've created a NAT gateway, we've created an entry in our route table to point to it, and we've launched an instance in a private subnet. Now the only difference from this diagram is we've also launched a bastion host, a jump host in the public subnet. So what we're going to do now is we're going to SSH into the jump host, SSH from there to our private instance, and then we're going to try and ping something on the internet to see if it works. So let's get the public IP of our instance in the public subnet. This is our jump host, and we're going to do SSH-A for agent forwarding and put in that address. And we're into that instance. And now we're going to SSH into the instance in the private subnet. So let's go and get the private IP address and connect in. And we're in. So that's great. Let's see if we can now ping google.com. And we can. We get a response. We could do sudo yum update -y. And we get all our updates. So we're on the internet now. We can access resources on the internet from the instance in our private subnet using our NAT gateway. So that's awesome, guys. Now you know how to use a NAT gateway. These are definitely recommended by AWS. So in most instances, you're going to choose a NAT gateway instead of a NAT instance because of the advantages we went over in the theory lesson. So let's just go back to our console. And what we need to do now is we're going to leave these two instances running because we're going to be able to use these in the next lab. But what I want to do is go back to VPC, and we need to get rid of our NAT gateway. Now you do pay for NAT gateways, so you do pay for them being used. So what I want to do is just delete my NAT gateway. It does have an elastic IP address, so what we'll now find is that we have elastic IPs, and we need to actually release this elastic IP. So we can try and disassociate it. It might not work because it's actually associated to the NAT gateway. So what you'll have to do is just wait for the NAT gateway to be deleted, and then make sure you remember to get rid of your elastic IP so you don't pay any money. So that's it for this lab, guys. We've covered NAT gateways, and in the next lab, we're going to cover NAT instances. Hi guys, we're now going to create a NAT instance. So I just wanted to put this slide back up just to remind you some of the pros and cons. Again, NAT gateways are the ones that AWS have recommended. For most use cases, you're going to use a NAT gateway because it's managed for you, it's elastically scalable, it has HA, and so on. But you can't add security groups of your own, and you can't use it as a bastion host. So there are a couple of advantages to using a NAT instance. You might want to use it in some scenarios, and that's what we're going to do in this lab. So we're going to create this configuration. We're going to have an EC2 instance in a private subnet, and we're going to have a NAT instance in a public subnet. And we're going to create a route table entry that points to the NAT instance for any IP address destinations that aren't within the VPC. So that's what we're going to do. And we can also use this NAT instance as a jump host so that we can SSH into the NAT instance across to our private instance and then ping the outside world via the NAT instance. So that's something that we weren't able to do when we set up our bastion host in the original bastion host lab. So that's what we're going to do. Let's head over to the console and get this set up. So I'm back in the EC2 management console, and we already have a couple of instances running. Now I'm going to keep my private instance, but actually I'm going to just terminate this instance in the public subnet because I still want to show you how you can use a NAT instance as a bastion host. So let's go to launch an instance. And what I want to do now is actually search for community AMIs. And I'm going to type amzn-a, it's corrected it for me, so let's just make sure it doesn't, -ami -vpc-nat. and let's just search. And so you get a list of AMIs, so Amazon Machine Images, that are pre-configured. And I want to use this one, this NAT HVM. And this might look slightly different when you search, but if you just put that in, you'll be able to find your AMI. So we choose select, we keep it as a T2 micro. We want to put this into our public subnet, and we can then go to security groups, and I'm just going to choose web access. So what we need from this is we need SSH inbound because we want to use it as a bastion host, and for the outbound we need to be able to send traffic out to the internet, and that's already allowed by default in the security group. So let's choose review and launch, and launch. So that instance is launching, and there's a couple of things we need to do. We need to go to actions, networking, and change source destination check. So by default, an instance in EC2 does not allow port forwarding, and we need to enable port forwarding for it to function as a NAT instance. So we choose yes, disable, and we can then take the public IP address and head over to the console, and we're going to SSH into this box. So I'm going to SSH, and I'm going to use port forwarding again, as we did in the previous labs, and I'm going to put in the public IP and choose yes. And I'm now going to SSH into my instance in the private subnet. So let's go back and get the IP of my instance in the private subnet. And I just need to put an @ sign in there. So let's just do that. And there we are, we're in. So let's see if we can ping google.com. And we're not getting a response, because remember, what we need to do is actually add an entry into the route table. So let's go back to our console, and I'm going to go to VPC, open it in a new tab, and we're going to head down to route tables and choose route table 1. Now we've still got this target for our NAT gateway that we had in the previous lab, and because that's been deleted, it says black hole. So what we can do is we can just delete that out, and I need to get the instance ID of my NAT instance. So this one with the public address is my NAT instance, and I need to copy the instance ID, head back to routes, add a route, and it's going to be 0.0.0.0/0, and then I'm going to choose instance, and it was this one here, so I don't need to paste it in, I can just choose it from the list. I remember it was the one that finished with F1. So let's choose that and click Save Routes. And we now have an active route via our instance, and you can see it's changed the target to the Elastic Network interface of that instance. So let's head back over to the command line and let's try and ping. Hi guys, I just got disconnected, so I had to clear my screen, but I pinged google.com and I still got a failure. And the reason for this is what we need to do is go back to our web access group, security group, and choose edit rules, and we need to add a rule to allow ICMP traffic, and I'm going to choose from anywhere and choose save rules. And if we go back to the console now and we ping, there we go, we get a response. So that's all working. So we have our NAT instance, which is also functioning as a bastion host. We've created the NAT instance from the Amazon AMI for VPC NAT. We've added a route table entry to point to the NAT instance in the route table for the private subnet. And we've also had to enable ICMP inbound to get the response traffic that comes back when we send our pings. Of course, we already have a rule in our security groups to allow all traffic outbound, so we didn't have to change anything there. So that's the configuration, and we're now able to SSH in to our instance via our NAT instance, and then ping the outside world via the NAT instance. So that's enabled internet connectivity. So that's all it is for NAT instances, guys. Let's go back to the console, and what we can do is, firstly, I'm going to remove the ICMP rule here because I use this for internet facing instances, so I don't want everything to be able to ping me, and save rules. And then I'm going to go and terminate my instances. Let's choose both instances here. Let's go back to the VPC management console, and what we're going to do is just go to our route table and we can remove that entry, which is now going to a black hole. And that's everything cleaned up for this lab. And we're now all done with NAT gateways and NAT instances. Some students have had difficulty connecting to the instances in the private subnets using agent forwarding when they're connecting from a Windows PC. So in the labs, we've done this and we've used agent forwarding using SSH. And when you use Windows PC, you have to use PuTTY and a tool called Pageant. And I want to show you how to do that in this lab, just to make it absolutely clear. So the configuration is going to be much like this. We have a private subnet, we've got a NAT gateway for outbound internet access, and we're going to be connecting from a Windows PC on the internet, and we're going to connect to our jump host here, and then from our jump host we're going to connect to the private instance. But the point is, we don't want to have any keys stored here, so we're going to use agent forwarding from the Windows PC, so that once we've connected to this one, we don't need to specify a key pair in order to connect to the private instance. So let's head over to the console and let's see how we can do this. Now, before we get started in the console, I just want to show you, if you search for agent forwarding AWS EC2, one of the first articles that you're going to find here is securely connect to Linux instances running in a private Amazon VPC. And if you come down here, it gives you all the information about how to do this using SSH, and then it also shows you how to do it on Windows. And so we're basically going to follow the instructions here, and I'll walk you through that now. So the configuration is we have our instance in a public subnet, and we have an instance which is in a private subnet. So all it has is a private IP address. Now I have a Windows virtual machine running on my computer, and I have PuTTY installed, and I've also got my key pair file saved as a private key file, so a PPK file, which we can use with PuTTY. And I showed you how to do that earlier on in the section. So what I need to do first is I'm going to go to this tool called Pageant, and I click on Pageant, and you'll see that a little system tray icon pops up. And if I double click on that, we can now add a key. And I'm going to choose this key on my desktop, so this is the PPK file, and click on Open. Now, if you've configured a password, you'll have to put the password in, but I didn't do that. So if I just close that, I now have the PPK file, or the key pair, actually loaded into Pageant, and it's going to now forward that on for us. So what I do is I open PuTTY. I just want to change a setting here, and then we need to go down to SSH, auth, and I don't specify a private key file here. All I do is click on Allow Agent Forwarding. So you don't need to specify the file. And then I'm going to go up to Session, and let's connect to our public instance. So I just need to get the IP address, and I don't actually have the clipboard working on this, so I'm just going to have to type this in. So I still need to do EC2-user at, and let's put in the IP, so it's 52.62.87.112. And now we just click Open. And so we're connected to our EC2 instance. If I just expand this so that it's a bit more clear for you. And what I want to do now is get the IP address of my private instance. So that's 10.04.100. So I shouldn't need to specify a key pair file now. I just need to do SSH EC2-user at 10.0.4.100 and hit enter. And there we are. We can now see that we're connected to 10.0.4.100, and that's our instance in the private subnet. So that's how you do it. You know, the instructions are there on the AWS website as well, so you can easily follow through on those. But that's how you connect. So the key thing to remember is you've got to set up the Pageant tool. And when you install PuTTY, that will be installed by default. So you get a couple of tools. You get the PuTTygen and the Pageant. So just add your key pair file to Pageant. And then when you connect, allow agent forwarding, but don't specify your key pair file. When you launch your EC2 instances, you can choose to put them in a placement group. And what happens is when you launch multiple EC2 instances, normally they'll just get placed on the underlying physical hardware in a way that you have no control over. So you don't really know if, let's say you launch 2 instances that are part of some kind of application cluster. You don't know whether they're sitting on the same underlying host, the same physical server, or whether they're spread across different servers. Now, because of application clustering, you might want to control that. You might also want to make sure that your instances are placed very close together so they have better node-to-node communication. So that's what placement groups are. Now there's 3 different types. We have cluster, partition, and spread. So with the cluster placement group, this is where your instances are placed very close together inside a single availability zone. And this means that you get really low latency, and node-to-node communication is low latency and fast because they're close together. So think about tightly coupled applications, and think about high performance computing or HPC applications. I know in the SAA C02 version of the exam, high performance computing is starting to show up. Now at this stage, while I'm recording this, the beta has completed and the actual final release of the exam is scheduled for a couple of months' time because it's January 2020 at the moment. By the time you watch this, that may not be the case. You might already be studying for the SAA C02, and if so, make sure you understand high performance computing. And we'll talk a bit more about the different types of adapter that you use for high performance computing as well shortly. So we then have the partition placement group, and this is where your instances are spread using logical partitions so that you know that one group of instances does not share the same underlying hardware as another group. So you can have multiple instances on one host and multiple instances on another. Now I'll show you some diagrams shortly so that all this makes a bit more sense. We then have a spread placement group. And what this means is that you have your instances spread across distinct underlying hardware. Again, the diagrams will make this easier. So let's go through and have a look at some of these diagrams. So this is what a cluster placement group looks like. And you see that there's multiple EC2 instances within a single availability zone. And we know that these instances are going to be placed very close together, so on hardware that's very physically close. And that means that you get better inter-node communication. So good for high performance computing, good for tightly coupled applications, and good to make sure you have that low latency and good bandwidth between the instances. Now, you use enhanced networking, and that means you're going to use an enhanced network adapter or an ENA. So we then have a partition placement group. And here we can see that we can use multiple availability zones. And we have a partition here with a number of instances in it and another partition. And we know that these partitions are going to be located on separate AWS racks. So there's a layer of resiliency there because each rack has its own unique power sources and backup power sources. And obviously there's networking that's redundant as well. So you now know that you've got a cluster here which is in one rack, and you've got another cluster in another rack, and you've got another cluster of instances that's in another rack and another availability zone. And we then have the spread placement groups. And in this case, what you can see is each instance is actually located in a separate rack. So each of these red lines corresponds to a completely separate rack. So a rack, is a sort of closet that you put your servers into, and you have lots of different servers in them. And each rack is therefore going to only have one instance that's part of your application. So there's lots of resiliency there. You know that in this case, you have 5 EC2 instances that are part of your application. And you know they're spread across 5 different racks. And each of those racks has its own redundant power and networking. So lots of resiliency for your application. We're in the AWS Management Console, and I'm just going to head over to EC2. And you may notice that as this is a newer video, the look and feel of the EC2 console is changed a bit. So we can see up here I'm actually using the new EC2 experience, and you can easily switch that off if you want to. It's not a huge difference, but there's just a few enhancements. Now we're just going to scroll down to placement groups under networking and security. And what we can do now is we can go in and create a placement group. And so I'm going to create my cluster PG for placement group, and I'm just going to choose the strategy cluster. and we can choose create. And then we can go back in and we can create a spread. And I'm going to call that my spread PG. And let's just go in and also create a partition placement group. And this is the only time that you need to specify the number of partitions. So let's just choose 2. And it says the maximum number is 7. So we've created all of those, and that's really all there is to it. And what we can do now is go to instances and launch an instance. Now what I'm going to do first, I'm just going to carry on as per normal and choose the Linux 2 AMI and the T2 micro. And we can see here that we can choose to place the instance into a placement group. So let's have a look. Let's add to an existing placement group. And what we can see is I can add these into a my partition placement group, and I can add into the spread partition placement group that we created. But as you can note, there's no cluster placement group here, and that's because the T2 micro cannot go into a cluster placement group. So there are specific requirements on what instance type you can add. So let's just cancel out and try again. I'm still going to choose the Linux 2 AMI, but let's go down and try a C5 large. Choose next, choose to add to a placement group. And now we can choose to put it into the cluster placement group as well. And we're not actually going to go and launch any instances now. I just wanted to show you where you go to create your placement groups and then how you can actually specify the placement groups when you launch your instances. So when you add to a placement group, EC2 will then automatically ensure that the policy for that placement group and how your instances are placed on the hardware is followed. Now let's just go back to the slides, and I've got one more here for you. And this just compares the different types of placement groups. So we've got the clustered, the spread, and the partition. So with clustered, this is about placing your instances into low latency groups within a single AZ. And you use it to get low network latency and high network throughput. And remember, you can use an enhanced networking adapter with your clustered placement group. It's recommended that you do launch all your instances up front, though you can add them later on. With a spread placement group, your instances are spread across underlying hardware. And this reduces the risk of simultaneous instance failure if the underlying hardware fails. And that can also span across availability zones. You can have a maximum of 7 instances running in a spread placement group per availability zone. We then have the partition placement group. And in this case, the instances are grouped into logical segments called partitions, and they each use distinct hardware. And you use that to control visibility into your instance placement. We then have the partition placement group, and in this case, the instances are grouped into logical segments called partitions, and they use distinct hardware. So you can control the visibility into your instance placement. This reduces the likelihood of correlated failures. So, if multiple racks go down in AWS, then you can ensure that your application stays running because you've spread your application across lots of different racks and lots of different underlying hardware. So that's it for placement groups. Now, in the exam cram at the end of the section, I'm going to talk a bit more about the different adapters that you can use with high performance computing and also for enhanced networking. So the elastic network interface, the standard type of adapter, the enhanced networking adapter, the ENA, and also the elastic fabric adapter.